So first we're going to start out by looking at 3.7, okay, which is on solving systems of equations graphically. When you're solving a system, you're generally solving for more than one variable. Okay, we're going to look at systems that have two variables. And generally the kind of systems that we look at, we can solve, some of them we can do algebraically, and we'll do one with algebra, but we're going to focus mostly on graphing. Does anybody remember the name of one of the methods you can use to solve a system of equations? Yeah?
Substitution.
You can do substitution. That's one method. Anybody remember another method? Yeah?
Elimination.
Elimination. That's another one. You can also do graphing. It doesn't work so well when you do it by hand, but on a calculator it's perfect because you can do an intersect and find an exact answer. So when we solve a system, we're generally going to be looking for two variables. Okay, that's the systems that we're going to do. Okay, they're going to have two. And usually the letters are going to be like an X and a Y. We're going to be looking for where graphs cross. Okay, when you're trying to describe where a graph crosses, it has an X and a Y value. And what do you call that when you put the X and the Y together? Those are a coordinate. So when you write your answer in this section, you can write it, we can write it two ways. You can either do it as a coordinate, or another way you might see it, like on Edge Elastic, you might see X equals, and then you have a box, and Y equals. But the point is you need to find an X value and a Y value, and together that makes up one answer. Okay, that's a coordinate. There could be more than one place where graphs cross. In general, if you draw two lines that have different slopes, how many times could lines cross at most? Just once with different slopes. Right? So there'd only be one solution. But let's say you had a parabola and a line. Well, now you get two. Right? So you need to find all. Right? And each answer has two numbers, an X value and a Y value. So in a problem like this, how many numbers would you be writing down?
Four.
Yeah, you'd be writing 4 numbers down. Yep. So when we're solving graphically, what we're going to do is calculate where they cross. Does anyone remember on the calculator what you press to find where they cross?
Isn't it second calc 5?
Yep, it's second calc, and then it's the fifth option down, which is intersect. Whether or not the guess matters when you do that, well, it depends on how many times they cross. Okay, if they only cross once, no, it doesn't matter. If they cross more than once, you need to put the guess closer to the one you want. Okay, any questions on that? All right, so I've got 3 different questions that we'll take a look at. And here's the first one. Now, they want us to solve that graphically, but if we try to look at the y equals screen, how come we can't type in what we have there directly on the calculator? What do we have to do first?
Yeah, you gotta make sure y is by itself.
Right, we gotta make sure y is by itself. So what I'm gonna do, I'm actually gonna move this one over here. All right. So both of them, we gotta get y by itself first. Well, Corbin, what would be my first step on this one to get y by itself?
Move 2x to the other side.
Yep. And how would you move it?
Subtraction.
Yep. So we'll subtract 2x. It's going to leave me with 3y equals. And Brady, if I'm thinking about writing this in like y equals mx plus b form, how would you write the right-hand side?
Negative 2x plus 5.
Yeah. Okay, so there's your first step. And Riley, what's my last step to get the y by itself?
Divide everything by 3.
Perfect. You divide everything by 3. there's basically your first equation for y. Negative 2/3 x plus 5/3. Right, now we'll do the same thing on the second one. Andrew, what's my first step to get y by itself here?
Add 3x on both sides.
Yep. Add 3x. And same thing, can you tell me like Brady did? If we're going to write it in like y equals mx plus b, what would the right-hand side be?
3x plus 21.
Yep. 3x plus 21. And TJ, my last step to get y by itself?
Divide everything by 5.
Divide everything by 5. And there you go. Now, when we type it in, we just got to be careful because we have some fractions. So I'm going to show you 2 ways you can type in a line that has a slope that's a fraction. The first way is like this. You can type negative 2/3, close parenthesis, and just put the x on the outside. And then plus 5/3. So that's one way. Or the other way you can type it is you can put the x in top. Right? You can type it as 3x over 5 plus 21 over 5. It doesn't matter which way you do it. I've just shown you two different ways. Any question on either way that I typed it in? Okay, so the left side, I put the x on the outside of the parentheses. On the right side, I put it in the top. What you don't want to do is put it in the bottom. You can't put the x in the bottom. All right, and then let's do zoom 6. These are lines with different slopes, so we know that they can only cross once. All right, so we can see where they cross. To find an intersect, it has to be on the screen. The calculator can't find it if it's off the screen. So this time, zoom 6, that worked fine. Now, second calc, intersect. And it's going to ask you to pick a point on each thing that you're trying to find where they cross. So pick a point on the blue, then the red. Now, does the guess matter? No, because it's only going to cross one time. So just put the guess really anywhere you want. And let's put our answer down there. So when you write your answer, both those numbers have to be part of it. So you can do it just like that. X equals negative 2, y equals 3. Or what's the other way I said you could write it?
Yeah, like a coordinate form.
Yep, you can write it as a coordinate. Either way. Okay. Any questions on that? Okay, so that one had a little bit of work because we had to get the y by itself first. Okay, the next one, the y's are already by themselves. And this time, they're not asking us to solve the problem. What are they asking for? Yep.
The number of solutions.
The number of solutions. So how many times do the graphs cross? All right, let's type these in. Let me go like this so you can see it. I think that'll work. All right, so let's clear out what we had there. Type in negative. Remember, for the negative, you got to use the button down by the decimal below the 3. Don't use the minus on the right. That's subtraction. So negative x cubed 3x squared plus x minus 3. Doesn't matter which one you put in y1 or y2. You just have to put one of them somewhere and then put the other one somewhere else. Okay, negative 2x squared plus 5. So the top one is a cubic. What's the bottom one called? Because the highest exponent's a 2. Yeah?
What would be quadratic.
That's quadratic. So we're graphing a cubic and a quadratic. So remember, cubic can look something like this. And a quadratic could either open up or open down like that. How many times do you think those two could cross each other?
Twice.
Twice?
Or 3 times.
Yeah, if everything lined up just right, well, I break these up. You could get it 3 times if they did something like that. That cubic might also go the other way in this one because of the negative, so it might actually look more. Might look more like this. Yeah, it's going to look more like the one on the right because the negative flips. All right, let's hit graph. So the one in blue that you're going to see first, there's your cubic. And the one you'll see in red is the quadratic. Okay, so let's look at that a little closer. And how many times does it look like those cross?
There is.
They're going to eventually.
It looks like 2, but it slowly
just
converges
you'll
down.
see it there.
Yeah, if it's not on the screen, it counts. So you may have to look for things that are off the screen. And it looks like the red and the blue are getting closer and closer. So if we go, which one of these do we have to adjust? Yeah, the Y min. They're not getting close very fast. So I think you do have to go down quite a bit. I think if you go to like -50, that'll be enough.
Nah, they get close pretty quick.
You think that's too much?
No. Might be a little.
Maybe like -40.
Yeah, -40 might have worked too. But you gotta go down quite a bit to see it. Okay. All right. So what's the answer to the question then? 3. Yeah. How many solutions? There are 3. And if you were going to find all 3, how many numbers would you be writing down? 6. X's and Y's for each one. I don't think they asked.
No, wouldn't it only be 5? Because the Y's repeat.
The Y, do the Y's repeat?
It just kind of looks different.
I think all the Y values, they're all going to be at different heights. All the points. Like you have this one up here, and you have this one right there, and then you've got one, down there.
From my perspective, those look the same. Sorry.
Yeah, so we want to write down each number. Even if they did repeat, you'd still write X comma Y. You'd write it in each coordinate. Yep. All right, let's try this one. Let's just do it algebraic. So to solve this one, we're going to use a method that somebody mentioned when I said what's the different ways you can solve systems. Yep, we're going to do substitution. Let's see. So with substitution, you take and you got to get a letter by itself. Well, they both already have a letter by themselves, so that's perfect for substitution. And then what do you do with this x cubed minus x? Yeah.
Substitute that for y in the next equation.
Yeah, you take that and you plug it in right there. So you're going to have x cubed minus x equals 3x. Now, when we're solving equations that have higher exponents, like 2's and 3's, does anyone remember what we usually like to get it equal to? Yeah?
0.
Yeah, we want to get it equal to 0. So the easiest way to do that would be to move everything to the left. And how would I move the 3x to the left side?
Subtraction.
Yep. So subtract 3x. So that's 0. And what do I have on the left side if I do that?
X cubed minus 4x.
X cubed minus 4x. Now, if there's anything that they both have in common, we want to factor it out. Is there anything I can factor out from there? Yes. I can factor out an x. And what would that leave me with in the parentheses, Brady?
X squared minus 4.
Now, x squared minus 4, that's a difference of 2 squares. So that means it can be factored again. Anybody remember how x squared minus 4 factors? Yep.
Is it x plus 2, x minus 2?
Yep. Now we've broken it down, we've factored it as much as we can. We just have to find the 3 numbers that you could plug in each factor to make it 0. So we want to probably make a table. What could you plug in for x?
0.
Yep. And then the second factor? Yep. And the third factor?
2.
2. Now there's supposed to be how many numbers when we're done for our answers?
3.
Well, 3 coordinates.
6.
6 numbers. We've only got half of them. What do we have to do with those 3 numbers? Yeah, we got to plug them back in. Does it matter which one we use? No. You can use either one.
I think it'll be easier to use that.
Yeah, I think y equals 3x would be easier. Yeah.
Can you just clarify what happens, not at the top, like at the beginning of the problem? What happens there? Why does that do that?
You substitute.
Yeah, we're substituting. We know from the top equation that y equals this. So we're going to change y in the bottom equation to what we got in the top equation.
I misunderstood. I didn't know those were 2 equations. I misunderstood. I
Yep.
thought the top equation was turning into the bottom. And I was really confused. Okay.
So
thank
2 different equations. Okay, so which one did we decide is easier to substitute back into? Yeah, y equals 3x. Just take your x value and triple it. So what's going to be your first y value?
0.
Your second one?
-6.
And your third one? Yep. And there's one way you could write all your answers. So if you were to graph this one, how many times would they cross? 3 times. And where they would cross are those 3 coordinates right there. 0, 0, -2, -6, +2, +6. And that's really it for 3.7. That was all there was.
Can you scroll back up for a quick second?
Any question on that? Now, it did say to solve graphically. I erased that part. You could solve it graphically just like we did for the first problem. Is there any question on how to graph and find an intersect? What if you had something like this? And I wanted you to plug that in. What did we say you have to get by itself first?
Y.
Y. How do you get y by itself there?
Square root.
You take a square root. And when you take a square root, what do you have to be careful about doing? Well, like if I asked you, what's the square root of 4?
2. Positive, negative.
Positive and -2. So when you take the square root of both sides, it's a positive and a negative. So you've got to be careful. Sometimes when you solve for y, especially when you have to take a square root, you have to separate it into 2 separate things. So this one equation is going to, you can't do plus or minus on the y equals. You'd have to type it in like this. Square root x minus 5 and negative square root.
We're going to be
X
seeing a
minus
lot of problems like that.
with a square root in it. Yeah, you'll see that again this week. Any question on how we got y by itself there? And then when you graph it, there's the top half, and there's the bottom half. Okay. So square root, it's a sideways parabola. That's what it looks like. Any question on that?
For cases like these, there's no like specific key for just plus minus and then a whole.
No. No. And then you might have another equation you'd have to type in. Maybe you have something like y equals -6 plus x. So in that case, if that was your problem, how many times do they cross? Twice. What some people mess up on is they forget about doing the positive and the negative square root. So if you forget the negative, you're going to lose one of your answers. Okay, so just keep that in mind when you're taking the square root. There's always two.
How do you get the y value when you substitute? I think I missed that part.
How do you get the y value?
Yeah, because you substituted. Oh, you just plug it back in, right?
You just plug it in.
Okay.
Now, if the top one was something like this, let's say y equals, no, I don't want to do it that way. Y plus x equals x cubed. Well, now you're going to get y by itself first. So you'd have to subtract the x to the other side.
Alright.
So if y is not by itself, that's the first thing you do. If it is, then you can go right to substitution. Any other questions on 3.7? All right. So let's look at 4.1. All right, so for the rest of this week, we're going to look at two sections, 4.1 and then 4.2. The goal is to get most of 4.1 done today, and then 4.2 we split into 2 days, and then Thursday will be a review. Let me show you an example of what a rational function looks like first, and then we'll kind of go through what it is in words. Okay, that's a rational function. 1 over x plus 2. That's a rational function. A little bit simpler, just 1 over x. That's another rational function. That's a rational function. 2x minus 13 over x minus 5. Okay. What do you notice about every problem I just showed you? They're all what?
Fractions.
They're all fractions.
Can you go back to the last one?
Hmm?
Like one after that? After that? Okay.
I think that was the first one. So they're all fractions. That's the point of a rational function. It's a fraction. So a rational function is written as a fraction where you have something in the top and then you have something else in the bottom. What's in the top and what's in the bottom are polynomials. Here's another example. X squared plus 3x minus 4 over x plus 1. That's a rational function. It's a quadratic polynomial in the top. And what about in the bottom? What do you call something that the highest exponent is a 1? Step down from quadratic. What do you call something that's a degree 1?
Linear.
Linear. So this is quadratic polynomial over a linear polynomial. Here's another one. X cubed plus 2x squared minus 5 over x squared plus 7. That's a rational function. It's a cubic in the top. What kind is in the bottom? A quadratic. Yep. Now there's a little bit of a difference between the two. I use different numbers, right? But that the highest exponent, it doesn't really matter. It's just as long as you have a polynomial in the top and a polynomial in the bottom. Sometimes you'll have one like this. What do you notice is different about that one in the middle than the other two?
The higher degree polynomial is on the bottom.
Yes, the higher degree polynomial is on the bottom this time. That's easier. When the higher degree polynomial is on the top, it can be a little bit harder. But they're all rational functions. Okay? Now, The top is a polynomial, the bottom is a polynomial. There is one thing that the bottom can't be, though. What are you never allowed to let the bottom be? Yeah. The bottom cannot equal 0. If it did, then you wouldn't have a rational function.
Does a rational function need to be rational?
Well, rational means it's a fraction.
Oh.
So it has to be able to be a fraction. Yeah. So here's another example. A little bit simpler than the top ones that I gave. But that's a rational function. There's another one. In one case, the bigger exponent is in the top. In the other case, there is no bigger exponent. They're equal. So there's really three things that can happen. The bigger exponent can be in the top, can be in the bottom, or there is no bigger exponent and they're the same. When the bigger exponent is in the bottom, or they're the same, that's pretty easy to do what we need to do. Okay, and what did we say you can't have in the bottom?
0.
0. So for this one, what are you not allowed to plug in for x?
3.
Yeah. So if we ask what the domain is, we would say it's all numbers except 3. And that's what we're going to do next. So the domain of a rational function is every number except numbers that would cause you to divide by 0. So it's all reals except any number that would cause you to divide by 0. So we'll try a couple where we find the domain now. So we're not really focusing on the numerator when we find the domain, focusing on the denominator. I think that's the same problem I just had on the board. So we already kind of did this. What was the domain in this one?
All real numbers except 3.
Okay, so that's one way you can write it. All reals except 3. I'm going to show you a different way we can write it, and I think we've done it before.
Isn't it like this symbol?
Yep, we're going to do something with the symbol. So you can't pick 3. Can you pick numbers lower than 3?
Yeah, negative infinity.
Yeah.
3.
Negative infinity, 2, 3.
And then 3. And then 3 to positive infinity.
Yes. Yep. So this means you can pick anything lower than 3, but not 3. And you can pick anything higher than 3, but not 3. So which way you write it just depends on the directions. If the directions say find the domain and it's open-ended, you can write it either way. If the directions say specifically write the domain as an interval, then you have to do the bottom. Okay, that's called an interval. Yeah.
Could you also write it as x with the equals and slash through at 3?
Yeah, that would kind of be like the top one.
Would you take that?
Under the same condition as what the directions say, yeah. So it just depends on what the directions say. Yeah. Okay, let's look at this one. Okay, this time the thing that's in the bottom, it's not as easy to figure out what you have to plug in to get 0. What can we do with what's in the bottom first? Yeah?
I was going to say 1 would equal 0.
Yeah, one would work, but there is another number. It's not as easy to find the second number. maybe some people aren't even sure how to find the first number, especially if the number isn't if it's like a decimal, it's going to be harder to find. What can we do with something like this? Yeah, we can factor it. That's how you find the zeros. That's why in the last problem in 3.7, I practiced factoring, because that's what we're going to do right here. Okay, if we want to factor that, what would be the first term in each parenthesis?
X.
Yep, it's going to be an x. And you've got a negative at the end. So what does that always mean your signs have to be?
Plus and minus.
It's got to be a plus and a minus. Now we need two numbers that multiply to give us 2.
2 and 1.
2 and 1, and I would do them
2 in the plus. No.
exactly like you said. Yeah, 2 and 1. Let's check it. So we get x squared minus x plus 2x plus 1x. Right, now we can see the two numbers that we're not allowed to use in the domain. So the domain is all reals except, what are the two numbers we cannot use?
-2 and +1.
-2 and +1. Now, if we write that as an interval, the last one had 2 sections. 1, 2. How many sections would this one have?
Wouldn't that have 3?
Yeah, think of it as like a graph. Here's -2. Here's +1. You can do anything down that way. You can do anything in here. And you can do anything that way. So if you have 2 numbers you can't use, that's 3 sections. If you have 1 number you can't use, that's 2 sections. How would you describe, let's start with this left section. Yep.
Negative infinity, comma, 2.
And what kind of,
It's just going to be the scoop. I don't.
No bracket or parentheses?
Oh, parentheses.
parentheses? So there's the left. How would you describe what's in the middle? Yeah?
Parentheses, -2, comma, 1.
Yep. Remember, parenthesis means you cannot include the number at the edge of the interval. Or, and how would you describe the last one? Yep.
Parentheses 1 positive infinity parentheses.
Perfect. So that, in the top, that would be a sentence. The bottom is an interval. Okay. Question on that one? All right, we'll try one more like B, except this time it's already factored for you. Let's just write it as a sentence. So I want to know the domain, but I just as a sentence. We don't have to do an interval this time. Yeah.
All zeros except for -2 and +4.
So all reals, yep. Except
-2 and +4.
-2 and +4.
Wait.
Yeah,
Yeah, but you don't put someone. And then +2.
Positive.
So all reals except +2 and -4. Because when you plug in 2 here, you get 0. And when you plug in -4 there, you get 0. Okay, any question on that? So all these functions we've been doing, these are all rational functions, but the simplest rational function you can have is that one. Just 1/x. So it's a constant in the top, and then a linear polynomial in the bottom. Just x. Let's graph that. So all of these functions that we're learning right now, these rational ones, none of them are going to be straight lines. Okay, they're usually going to have some type of curve to them. As far as having to get y by itself to graph it, that's not really going to be a thing in this section. The y, or f of x, is pretty much always going to be by itself. Okay, so not like 3.7. Now, if you had other things you needed to type in, like let's say you had a +2, then I would say, all right, we're going to need some parentheses so the calculator knows where to put the +2. But it's just 1 over x. So when you type it, you do not need parentheses if it's that simple. Okay. All right, let's do zoom 6. All right, so the calculator does a pretty good job. It's not exactly what it looks like. Okay, so there's your sketch. But when I look at that, at least the way the calculator did it, it almost looks like it kind of stops going up and it stops going down. It doesn't. What happens is because it starts to get almost vertical, the calculator can't draw things that get vertical. So it just gives up. So this piece really should keep going up like that. And this piece down like that. On the left and the right, it did that fine. It doesn't have a problem as things start to flatten out. Okay, so any questions on that graph? Okay, that's what the graph of 1 over x looks like. Now, I want to answer a question about that. First thing I want to look at is what happens as x heads to infinity. If you're heading to infinity on the x-axis, which way is that? Right. It's to the right. So tell me what's happening to the blue curve as you head further and further and further to the right.
It's getting closer and closer to x equals.
It's getting closer and closer to what? 0. Yeah. Now think about your graph. Right? This is what we typed in. Bless you. If x is 1,000, will y equal 0?
No.
No. What would it be?
1 over 1,000.
1 over 1,000. 1,000. If x is 10,000, would that make y 0? No. It would be 1/10,000. Will y ever be 0?
No.
No. Even if you plug in 1,000,000, then it's 1/1,000,000th. It's very, very small, but it never reaches 0. Now let's look at what happens as you head to the left. As x gets bigger as x gets to be a bigger and bigger negative number, what does it look like that blue curve is getting closer to on this side?
0.
It's also getting closer to 0. The difference is on the right, it's coming down to 0. On the left, it's going up to 0. But it's approaching 0 on both sides. Yeah.
Could you go back to the definition for 1 second?
Yeah.
Thank you.
So when we say that it approaches 0, what value is approaching 0 as you head to the right and to the left? The y value. And what's another name for the y value? F of x. Exactly. So as x heads to the right or to the left, the y value is getting closer and closer to 0. And there's a name for that. Does anybody know what that's called? Like something in math you get closer and closer and closer to, but you never reach it. Yeah?
Asymptote.
It's an asymptote. Yep. And this particular one is a horizontal asymptote. The way we generally show an asymptote is we can put it in as a dotted line. So I'll make it dotted. You don't have to make it dotted. I'm just showing you. The calculator can make it dotted, so I'm going to do it that way. And let me zoom in so it's a little easier to see. And the idea that is, if you head further left and right, you're going to see, it's kind of hard to see because it's right on the black axis, but if I shut the axis off, you can see it a little bit better. Maybe you can see it. There is a red dotted line right on top of the axis. And what's happening is the blue curve is getting closer and closer and closer to it. But it'll never reach it. It'll never reach it.
Never touch it.
Nope. Never touch it. Okay, so that's called an asymptote. So a couple things about an asymptote. We're going to look at horizontal ones and vertical ones. When you are writing what an asymptote is, you have to write an equation. And an equation always has a what?
Equal sign.
Always has an equal sign. Yes. Specifically, a horizontal equation always has y equals and then a number. That's the equation of a horizontal. Vertical is different. It's still an equal sign, but it's not going to be a y. It'll be a different line. Okay, but a horizontal asymptote is y equals and then a number. So the way that you find a horizontal asymptote is you look at your graph and follow it to the right or to the left. As you head further and further and further to the right, if you notice you're getting closer and closer and closer to something, that's your asymptote. Whatever you're getting close to but not reaching. There's a couple examples of asymptotes. So you can cross an asymptote, like this one right here. That's fine. The idea of an asymptote is that it doesn't have anything to do with what's happening when x is small. It has to do with what's happening as x gets bigger and bigger, like in the thousands, 100,000s, millions, as you head really far to the left and right. So in this particular graph, it crosses here, but then I can see it's getting closer and closer and closer and closer to that dotted line. Where that dotted line is, I don't know. I didn't put graph lines. Right? But that is an example of an asymptote, and so is the one on the left. Is there a question?
Yeah, is there a math way to find asymptotes, or do you just have to graph it and see which one?
Yeah, we're going to talk about, either today or tomorrow, we're going to talk about what's called an EBM. It's called an end behavior model, and that's a way that we can find the asymptote without drawing a picture. It's called an EBM. No, not today. Tomorrow. So EBM is something I'll talk about tomorrow.
Wait, can you go back to the example where you gave the
Some problems, you also see asymptotes actually that look kind of like this. And it actually, we're not going to do one like this, but it keeps crossing the line forever, but it never settles in on it. It's always oscillating a little above or a little below. The amount above and below keeps getting smaller and smaller and smaller and smaller, but it never stays at it. It keeps oscillating just a little bit above and below. We don't look at any asymptotes like that. Okay, ours are going to, as you head to the left or the right, they're going to get close but never touch it.
I get on that example how like when it keeps going down it never touches it, but it gets really, really close. How would it be an asymptote then if it actually crosses one value at a certain point?
So the idea is it's just a value that you're closing in on, but you never stay at it or reach it. And that's what would be happening in this red one.
So it doesn't have to focus on like the the whole scale of it. It just has to focus on like a certain section where it just never touches it. But it's
Yeah, as you head to the right forever or left. So in this case, it doesn't look like the graph has an asymptote as you head to the left. Maybe the graph starts right there. So there's no asymptote on the left. It's just on the right. And that's possible too.
But it's not based on like it has that one point where it crosses the asymptote. It's just the asymptote for the point or the section of the graph where it gets close to it, right?
Right, yeah. Yeah, there's no rule saying you can't cross an asymptote. At least a horizontal. Horizontal, it's okay to cross. Vertical is not. You can never cross a vertical asymptote. Ever. Never happens. Well, maybe I shouldn't say never, but I can't think of an example where it does. Yeah.
So, is an asymptote, like if you're trying to find an asymptote for something, right? And is it just like is it, it's x equals that goes like this, right?
X equals is vertical. We
Okay,
haven't
y
talked about that.
is the
Y
vertical.
equals
Okay, yeah.
is this way.
So is it it's just like y equals whatever one it's like closest to as it's going down? Is that what it is?
Yes.
Oh, okay.
Yeah.
Okay.
And we're gonna do an example where we find some asymptotes right now.
Okay.
Yeah. All right, so let's try this. So find the horizontal asymptotes of 1 over x plus 2. Now, this is one when you type it in, you do have to use parentheses.
Yes.
Yeah.
Plus 2.
If you don't, the calculator's going to think the plus 2 is in the bottom of the fraction. And that could be a problem, but it's not this problem. So 1 over x plus 2. Okay, by putting the 1 over x in parentheses, the calculator knows for sure the plus 2 is on the outside and it's not in the bottom. And I'm just going to do zoom 6 and graph it. And let's look at that. Can anybody tell as we head left and we head right what value it looks like we're getting closer and closer to? Yeah, it's going to be 2. Another way you can check it is you can use the table. I'm not sure if we've used the table, but you can press second table. And it's giving me a list of numbers in the table already. I don't want these numbers. I want to put in my own number. If yours is giving you a list of numbers and you press delete and the numbers aren't going away, I want them to go away. What you can do is press second window. And instead of having it automatically give me the x value, I'm going to have it ask me what I want for the x value. So that's second window. If you set it like that, it should always stay like that on your calculators. Now, what value are you not allowed to plug in for x in that one?
0.
Yeah, you can't plug in 0 because you'd be dividing by 0. To find the horizontal asymptote, look at what happens as you keep heading to the right. So what's a value that's to the right of 0?
1.
Okay, we can do 1. And now we want to keep going.
2.
Further.
10.
All right, 10. We're at 2.1. Let's go out to 50. 2.02. Okay, if we go to 100, 2.01. So now we can kind of start to see what we're getting close to. 5,000. 2.0002, just above 2. But does it look like it's ever reaching 2? No. Eventually, if you plug in a big enough number, it's going to run out of decimal places. Okay, so it might say 2, but if I highlight it, I can see more decimals. It's actually 0.00002. So it's never reaching 2. Yeah.
Is the asymptote always the value after the graph buckles?
Well, it ends up always being this number. But you're talking about,
Like looking at the graph, is it always the value after it bends?
yeah, it's whatever, yeah, what it's getting close to. That bend might be very gradual. I mean, you could have a bend that's like this. Yeah, it might be a very slow bend.
Oh, okay.
So it could be sharper too. It depends on the problem.
Okay, so it's not a good measurement.
Yeah, you want to try looking at the graph, as you go really, really far to the right or to the left. There it is. Now the same thing happens as you go to the left. What would be a value I could plug in that's headed towards the negative numbers?
Negative 5,000?
Yeah, I could plug in negative 5,000. And I'm at 1.9998. So just about at 2, but just underneath it. So when we write the equation, since this is a horizontal line, what letter do we start with? Y equals, and what number is the asymptote? 2. Yep. That's the equation of the horizontal asymptote. This plus 2 at the end ends up taking the graph and shifting it up 2. We learned that earlier. If you add or subtract a number on the end, it takes and shifts it up or down. So what do you think a minus 3 would do? Yeah?
The asymptote would be y equals -3.
Right. Normally it would be 0, but if you shift it down 3, everything goes down 3. So this time the asymptote is y equals -3. If you're not sure, you could graph it, and you'll see a graph that gets close to -3. Okay, any question on finding the horizontal asymptote? So horizontals, you look at what happens as you head really, really far away. 5,000, 50,000. Look at really, really far away x values. Okay. Now, instead of looking at what happens as I go really, really, really far away, I want to look at what happens as I get really, really close to the number that I'm not allowed to use. What number are you not allowed to plug in for x there? 0. Yeah, you're not allowed to plug in 0. So what I want to do is look at my graph, which actually I think I already have on the other page, and look at what happens as you get close to 0, like 0.1. 0.01, 0.001, like get really close to 0. Okay, so here's your graph. What happens is you're on this blue curve and you travel towards 0. Specifically, when you write this, that means as you travel towards 0 from the positive side. The right is the positive side. So what happens is we start on the right and travel towards 0. Yeah?
It's like exponentially larger.
Yeah, the graph starts to curve up. And what do you think it curves up to?
Infinity.
Infinity, yes. Now, how about as we approach 0 from the negative side? That's negative means the left side.
It goes down.
Yeah, as you start to get closer and closer to 0, all of a sudden it just drops off. Okay? When you have a graph that as you get close to a number, it goes up or it goes down, that's another kind of asymptote. Anyone think they know what kind of asymptote we have here? That's vertical. So a vertical asymptote is a line you get close to as you approach, in this case, the number 0. In general, it's the number that causes the denominator to be 0. That's usually where you have a vertical asymptote. So just to be clear about what that means, because you're going to see it on the test. When you see a 0 with a little plus sign, positive numbers are on the right. So that means it's coming at it from the right. If you see a 0 with a negative symbol, the negatives are on the left. So that means you're coming at it from the left side, heading towards 0. Any question about which side is which? Okay, so one side it goes up, other side it goes down. Just depends on which side you're coming from. And that's called a vertical asymptote. Okay, same idea as a horizontal. In the homework and on the test, when you write an asymptote, you need an equation. That means it needs to have an equal sign. If it's vertical, it's always going to be x equals. Horizontal, y equals. And there are asymptotes that are slanted. We're not going to look at those today. We're not even going to look at them tomorrow. We're going to do those on Wednesday. We're going to study verticals, horizontals, and slanted ones. There also are asymptotes that curve. So now you have a curve you're getting close to instead of a flat line. We don't get into the curved ones. Okay, so in general, what are you looking for a vertical asymptote? The idea of a vertical asymptote is as you approach a number, could be 0, could be 2, depends on the problem. But as you approach a number from both sides, the left and the right, your graph either curves up to infinity or down to negative infinity. In most problems that we do, as you approach it from one side, it's going to go down. From the other side, it's going to go up. Most problems. Okay, I'm going to show you a graph. I said most times one side curves down, the other side curves up. Here's a graph where they both curve up. That's still considered a vertical asymptote. They just both go up instead of one up and one down. I took the absolute value, so I made it positive. So instead of having a part that was down in the negative section, the absolute value basically flipped it up. Let's type in something here. Let's type in x minus 3 times x minus 4. I'm going to put parentheses around it. Okay, that's going to be my numerator. And then I'm going to divide by x minus 3. What value am I not allowed to use for x here? I can't use positive 3. Let's graph that. Let's see what it looks like. I can't use positive 3. Let's do zoom 6. Does it look like there's a vertical asymptote there? No. Even though there's a value we can't use, positive 3. Right? It's like right about there. Looks like the graph just went right through it without a problem. But if I go to the table and I type in positive 3, it definitely says it's an error. So the calculator agrees you can't use positive 3. What's happening there? Does anybody remember? Yeah?
Isn't that a hole?
That's a hole. So just because you have a value that you're not allowed to use, it doesn't always mean it's an asymptote. Right? In this graph, there's a hole, and the way we generally draw it, you should put a circle there. You shouldn't even draw the line in that hole. It should just look like this. That shows that there's a gap there. Does anybody remember why this graph has a hole? Because if I make this 3 any other number besides a 3, you will have a vertical asymptote. But why is there a hole in this graph? Yeah?
Because it cancels out the bottom.
Right, we have what's called a common factor. You have an x minus 3 in the top, and you have an x minus 3 in the bottom. When you have a common factor, you will get a hole. So let's make it so we don't have a common factor. What could I make that 3 instead?
5.
Sure, make it a 5. Now, as you get close to 3, watch what happens.
Who said 4?
There's a vertical asymptote at 3. So if you do not have common factors, then the number that causes you to divide by 0 is an asymptote. If you do have a common factor, then the number that causes you to divide by 0 is a hole in the graph. Yep. So let's write that down. So if the numerator and denominator do not have common factors, then you will get a vertical asymptote where the denominator is 0. If they do have common factors, you'll get a hole. So that one that I graphed on the calculator originally that just looked like a straight line, if I said to you, where are the vertical asymptotes, you would have said there are none. There was a hole. There were no vertical asymptotes. Okay, so any question on how you can tell whether you're going to have a hole in the graph or a vertical asymptote? Now, we already know how to find when the denominator is 0 because you got to do that when you want to find the domain. So it's really, if you are asked to find a domain, you're automatically doing this too. You're finding where the vertical asymptotes would be. Okay, let's look at 4a. Are there any common factors in the top and the bottom there? No. Just a 1 in the top and an x minus 2 in the bottom. Okay, to have a common factor, you would need an x minus 2 in the top and the bottom. So because we don't have any common factors, are we going to get a vertical asymptote?
Yes.
Or a hole? Vertical asymptote. Where is the vertical asymptote going to be?
2.
Yep.
2.
2. And how would you write the equation of it?
X equals 2.
Yes. If that was a multiple choice question, I would definitely put x equals 2 as a choice. I'd put y equals 2 as a choice. Right? Y equals 2 would be what? That'd be horizontal. That's not vertical. Okay. So x equals 2. Let's try this one. How about 1 divided by x plus 3 minus 1? What would be the vertical asymptote there?
-3.
Right, you're looking for the value that would cause you to divide by 0, which was what number?
-3.
And the whole equation would be?
X equals
What if I did this? What's the equation of the vertical now? It's still x equals -3. This affects the horizontal.
Yeah.
The only way I could change the vertical is if I change this number, not that number. Questions on that? Okay. Does anyone want me to show you how to type that in? The only thing you have to do when you type it in on the calculator is 1 divided by like that. You've got to put the x minus 2 in parentheses. All right. We're gonna skip that one, and we're gonna do the last one. We should finish it. If we don't, like I said, we have an extra day, but I think we'll finish it. So the last problem, it's a rational word problem, and it's going to involve a mixture. Okay, it's like a mixture problem. Now, if I said to you, in front of you, you have a container of 50 ounces of liquid, and out of that 50 ounces, 35% of it is acid. So 35% of the 50 ounces is acid. How do you find 35% of 50? And what's 35% of the decimal? 0.35, yeah. And just times it by 50. So that means if you had 50 ounces of liquid in front of you, and I said to you that in that 50 ounces, 35% of it is acid, that means you have 17.5 ounces of acid in the liquid, and the rest of it could just be water or something else. So any question on how to find out, if I give you an amount of liquid and a percentage that is in it that's acid, how you figure out how many ounces of acid? Okay. So what we're going to look at is how you find the concentration. Finding the concentration is pretty much the same idea as if I said to you, like, how many questions did you get? What was your grade on the test? If you got, there were 10 questions on the test and you got 7 right. How do I find your grade? Yeah? Right. I take how many were right divided by the total. In this case, it's not how many we got right, but it's how much acid. So it's the amount of acid divided by the total. That's how you find concentration. So if you had 10 ounces of acid and you had a 20-ounce solution, 10 out of 20 means you have a 50% solution. It's like getting 10 out of 20 questions right on a test. 50%. Okay, so here's our question. We're going to take that 50 ounces of acid and we're going to pour in X ounces. So we have a 50-ounce solution. We're going to pour in pure acid into the solution. So we're making the solution stronger. I want to find a formula for the concentration. What percent is the solution starting at? Starting at 35. It can't go any lower than that. I can either pour in nothing or I can pour in 100% pure acid. So I can make the solution stronger. That's all I can do. So I want to find a graph of the new concentration. Usually to represent concentration, we use the letter C. And the concentration is going to be controlled by how much acid we pour in. So to find the concentration, you have to divide two things. The amount of acid that you have now and the total liquid that you have. Well, there's acid coming from two sources. There was already some acid to start with, and then we're going to pour more in. How much acid did we already have to start with? We had 50 ounces in total, but only 35% of it was acid.
Soon we get
17.5.
Okay, so that's how much acid you're starting with. How much acid are you adding to that? Right, we're going to add X ounces of acid. So that's how much liquid you started with. You started with 50. And how much liquid are you adding? X. You're adding X. So that is a formula for the concentration. That'll give you the concentration as a decimal. In other words, it'll be between 0 and 1, which represents between 0 and 100%. All right, let's graph it. When you do it, just put it in parentheses. 17.5 plus X divided by 50 plus X. Now, if you don't set your window right, this is going to look like a flat line. You just can't even tell what's going on there. What's the lowest amount of acid that you could pour in?
0.
You can't pour in less than 0. The maximum, well, there's no limit. Just depends how much acid you have available. Why min? That's the lowest that the concentration could possibly go. The lowest it could go is 0.35. And the highest? 100. And as a decimal, that's 1. So if you graph that, there's a graph of the concentration. The more and more acid you pour in, the higher and higher the concentration gets. But the concentration will never reach what?
100%.
Why can't it reach 100?
Because it's only 35% of the original.
Right, you didn't start with 100, right? It's like if I gave you some like white paint and I put a couple drops of black in it. You can't get that black out. You can keep pouring more and more white to make it less and less and less, but it's still in there. So it'll never be pure white paint again. It still has a little bit of the black in it. Right? So that's how you do your concentration. And the last thing they want to know is they want us to create a 75% solution. So to find out where this graph hits 75%, what do you think I'd need to do?
Do a line at 75 and then intercept.
Yeah. I'm not going to finish that whole thing because I won't put up the homework. But yeah, you put a line at 75% and then see where they cross. And that would tell you how much acid to pour in. And we can do another one of those tomorrow.
How did you enter that into the calculator again?
How did I put that in? Just like that. There's a parenthesis before the 17.5, you just can't see it.
Yeah.
And again, there'll be a concentration one in the homework, and we can go through it again. Let me double check page 222.
On a whim.
Okay, so the first page, that's on finding some intersects, like we did with the systems. So that's 8, 9, and 10. And then on page 222, make sure on the 3 through 7 and 11 to 21, it's just the odds. I guess since I erased one, I could just make it 11 to 23 odd if you want. Simplify it.
Are we just doing A and D on 48?
And then on 48, I think it's parts A, B, and C. You just have to do part A and B.